Everyone looks at the future of urban air mobility, UAM, and sees eVTOLs, futuristic aircraft with tilt rotors or multiple propellers, promising to be the definitive solution. But what if I told you that the most efficient and feasible technology doesn't have to be a radical new design? What if the answer to UAM has been flying above our heads for decades and just needed to be electrified? The industry has focused on two primary eVTOL configurations: multi-rotors, which are simple to operate but highly inefficient in cruise flight, and tilt-rotor eVTOLs with fixed wings, which promise the efficiency of a plane in horizontal flight. However, this latter configuration introduces a huge complexity that has a direct impact on regulation and certification. An eVTOL must demonstrate compliance not only with helicopter requirements for vertical takeoff and landing, but also with airplane requirements for cruise flight. The most complex part is certifying the transition phase. The FAA must ensure the aircraft can safely shift from one flight mode to another, even in the event of a failure. Each new eVTOL design with a unique configuration requires its own set of special conditions and compliance methods. There is no single recipe. Additionally, flight autonomy, flight control software, the redundancy of multiple motors and battery systems, and new methods for electric power management must all be certified. This is where the electric helicopter comes in. Unlike eVTOLs, a helicopter operates with a single aerodynamic configuration throughout all phases of flight. Stability does not depend on the synchronization of complex mechanisms, a fundamental advantage in safety and simplicity. Robinson Helicopters, in partnership with MagniX, understands this. They are developing an electric demonstrator of their popular R66. This is not just news, it's a statement that UAM can be viable with proven technology that is also intrinsically more efficient at the heart of urban operations: hoverflight. The helicopter's main advantage is its low disk loading. This concept is described by the formula dl=W/A. The large single rotor of a helicopter provides a massive disk area, which drastically reduces the value of dl. What does this mean in practical terms? Lower disk loading means the aircraft needs to move air at a lower velocity to generate lift, which translates into superior energy efficiency in a hover. For example, in a UAM scenario where a helicopter must wait 10 minutes to land, its low disk loading might consume just 10 kWh. An eVTOL with a higher disk loading for the same operation could consume 25 kWh or more. At a cost of 20 cents per kWh, we're talking about a significant savings of $3 for every 10 minutes of waiting, and this adds up in constant operations. The simplicity of a helicopter means its path to certification is a known process. It's true that a tilt-rotor eVTOL with fixed wings is faster and more efficient in cruise mode. However, for UAM missions, which are often short trips within a congested city, that extra speed is not a significant advantage. The total mission efficiency, considering takeoff, climb, cruise and landing, can be superior in an electric helicopter. Furthermore, autonomous flight control systems are improving helicopter efficiency by optimizing blade angle and power at every moment of flight, which also adds simplicity to the aircraft's control and reduces the pilot's workload. The R66 demonstrator from Robinson is the tangible proof of all this. MagniX has developed an electric propulsion system with built-in redundancy. This means the system operates with two independent batteries and two motor controllers, ensuring that if one fails, the other maintains power for a safe landing. This redundancy is not a luxury, it's a key safety requirement for certification. Their Samson batteries have an energy density of 300 Wkg, which means they can store a significant amount of energy at a relatively low weight, enabling the necessary range for UAM missions. This engine, named Helistorm, was designed specifically for helicopters, optimized for the high power demands, and the goal is ambitious, to have it ready by 2026. The conversation about the future of UAM has just changed. What do you think? Do you believe the electrification of proven aircraft like the helicopter will be the key to viable urban air mobility? Or will eVTOLs ultimately prevail? Leave your thoughts in the comments below. If you like this technical analysis, hit like, share it, and don't forget to subscribe for more cutting-edge content in the aviation industry.